January 2024 was the hottest January ever recorded.
When you talk about the record heat of 2023, the hottest year on record, 2024 expected to be even hotter than that.
2024 is already a crazy year, but the coming months will be really crazy. I feel quite safe to predict that.
Records were broken coast to coast in more than a dozen cities.
A fiery nightmare sweeping through Texas. The Smokehouse Creek fire swelling to more than 1 million acres.
We are completely underestimating the near-term warming. Because of that, there will be many, many deaths.
The area burned in the country this year is quite literally off the charts.
Now, the average temperature of the world's oceans is at its highest since records began. It's believed to be rising faster than at any time in at least 2,000 years.
We should prepare ourselves for much faster sea level rise, much stronger storms, much more forest fires.
An extreme drought in Panama is forcing authorities to substantially scale back shipping through the Panama Canal.
The Amazon rainforest in Brazil is undergoing a severe drought. Many people in the region are struggling to access essentials such as food and water.
You're not informing people about the reality which is there, and that could cause very serious harm.
Cyclone Freddy's death toll in Mozambique and Malawi is officially more than 200. That number is expected to rise.
Thousands of people are still missing. As many as 20,000 people may have died.
The climate has already changed. We are in an uncharted territory. We're about to reach a climate within the next decade, which we maybe haven't seen for 1 million years. If you ignore it or you pretend it's not happening or even some lie about it.
It almost appears to me as though the IPCC is perhaps trying to manage public panic about this.
The IPCC process is keeping people ignorant.
Something happened in 2020 that fundamentally changed the current state of the world, and I'm not talking about the pandemic. This is a phenomenon which is causing weather records to be completely shattered all around the world, and the public is being completely kept in the dark about it. Here's how it works. The sun is what heats up the planet. Throughout the last century, we've been burning hydrocarbons to power civilization. These emit greenhouse gases like CO2, which trap the heat in the Earth's atmosphere. This in turn causes abnormal heating. But there's a catch. In addition to the CO2 that's emitted that traps the heat, the burning of these fuels also release things called aerosols, like sulfur oxide. This actually has the effect of reflecting some of that sun's light back out into space. This in effect actually cools the planet. So CO2 heats the planet, but these sulfates have a cooling effect, masking the true heating that's being caused by the CO2. These sulfates fall out of the atmosphere within a few weeks, whereas CO2 remains for hundreds of years. So what happens if we remove all the sulfur oxide from the atmosphere? Very bad things will start to occur. In 2020, this actually happened. The International Maritime Organization brought in new regulations that drastically limited the amount of sulfur in the fuel in the 50,000 ships that traverse the oceans. In theory, removing these sulfates is going to lead to better global health outcomes. However, the unintended consequence is that this strips us from the protective layer that is actually cooling the planet, causing rapid warming. In 2024, sea surface temperatures have been off the charts. This is going to contribute to droughts, wildfires, floods, and impact our ability to grow food at scale to feed the Earth's hungry population. Today's expert is going to break down what it all means. Hi folks, Canadian Prepper here. It's an honor today to have on the channel Leon Simons, who's a climate researcher and science communicator at the Club of Rome in Netherlands. He's currently studying the effects of the reduction in sulfur emissions on regional and global radiation changes and its impact on global heating. Now, if that sounds like a mouthful, don't worry, because he told me that he also gives this talk to high schools because his recent paper that he was a part of, Global Warming in the Pipeline, is very dense with information. And because I'm very dense, I'm hoping that he can break it down in a way which is very simple. We have a mutual acquaintance, Nate Hagens, who introduced us recently. And if you haven't seen our talk with natural resource expert Nate Hagens, I would encourage you to check that out as well. But Leon's going to talk about an X factor with respect to the current rising temperatures around the world that is often overlooked. So welcome, Leon, and can you tell us a little bit about your background and what exactly you do?
Yeah, hi, Nate. Thank you for having me. So I'm two things besides, of course, my private life. I'm a entrepreneur. I'm a social entrepreneur. I develop new energy technologies, especially for developing countries, with my company called Magic Ventures, where we bring technologies to people in need and to improve their lives, mainly around clean cooking. And about 4 million people die every year from the effects of using biomass for cooking, mainly wood, from indoor air pollution. So that's a bit related to the subject we're discussing today, because there's also these particles which affect health, but they also affect the climate. And next to that, I work for a think tank, the Dutch chapter to the Club of Rome. And that's where I do this research from.
And so tell us a little bit about the research that you are currently, or that you were recently a part of with James Hansen, this paper entitled Global Warming in the Pipeline. Can you tell us a little bit about, there's going to be some people in my audience who have a general familiarity with the topic of warming and greenhouse effect and these types of things, but not everybody is going to be familiar. So if you could maybe just boil it down to its bare bones components, what were the findings, or what are your most recent findings that were discussed in this recent paper that you were a part of?
Yeah, I think it's good to go back a bit to the basics. So this is research we published in the past year. Most people have heard about the effect of greenhouse gases causing warming. Here I show the main things that drive our climate, because we are pushing the climate into a certain direction. By emitting these greenhouse gases, we push the climate into a warmer state. But we are also emitting something else next to these greenhouse gases, which are called aerosols, and which are mainly from sulfur, because there's sulfur inside the fuel we burn, and that's causing a cooling effect, and that pushes the climate into a cooler direction. But of course, the warming effect from greenhouse gas is stronger than the cooling effect of the sulfur particles, and that's why we see a net warming effect. But the sulfur has been hiding part of the warming, but now we are introducing clean air regulations, and that causes a reduction in the sulfur emissions. And because of that, the Earth is warming, and it's warming faster than it was before.
So what you're saying is that we are warming the planet via greenhouse gases, but there's another forcing component that is the sulfur dioxide, which is actually masking the effect and reflecting some of the sun's light. Is that correct?
Yes. So greenhouse gases absorb infrared radiation and make the planet warmer, and sulfur particles reflect sunlight, and they make clouds whiter, and which also reflect more sunlight, and this causes cooling, especially regionally. Everything starts with the sun, of course. The planet is heated up by the sun. That's the external source of energy on the planet. And so what happens to all this energy reaching Earth, right? Well, about 30% is reflected. So that's just not heating the planet. But then a big part of that heat is absorbed. And now there's a change in how much is absorbed. You can see this yellow line is increasing. So more sunlight is being absorbed. But then this red line shows how much heat is going out. And if there's a difference between how much heat is being radiated to space compared to how much is absorbed from the sun, the planet heats up.
Now, what do you say to people who are, there's this idea that the sun and its intensity is what is driving the warming? Obviously, we know that the greenhouse effect is what's leading to the trapping of heat. But what percentage of changes in temperature on Earth are due to differences in sun cycles, like solar radiance?
Yeah, that's a good question. So there's indeed this cycle. There's a longer cycle, but there's a small cycle of about 11 years. The 11-year cycle, solar cycle, changes how much sun reaches the planet on average. The Earth is round, so you have to divide the total number by 4. And then for that variation is about 0.2 watts. That's what I show here in white. You can see there's a small fluctuation happening.
Okay.
Right. But the greenhouse gas forcing, so that's how much additional heat is being kept inside by these additional greenhouse gases, that's 4 watts per square meter. So this is a fluctuation of 0.2 watts, but the greenhouse gas causes an increase of 4 watts per square meter. And that's permanent.
So
and
is that
times 4.
Is that 0.4 watts or 4 watts?
No, 4.
4. So that's
even more than 4.
That's like over 20 times the amount of heat that is trapped compared to the variation, the natural variation.
Yeah, and that's indeed, and the natural fluctuation of that's about 0.2 watts, and this is the red line I show here. In red, I show the total greenhouse gas forcing, so how strong the planet is pushed into a warmer state, but that's 4 watts. But then there's this other thing, which is aerosols. And this is very uncertain. I don't show the uncertainty here. But that's about 1 watt of forcing in the other direction. So the climate is also pushed in the other direction.
So that's cooling the planet down to about 1 watt per meter, whereas the greenhouse gases are raising it 4 watts per meter.
Exactly. Yeah. And then that causes this imbalance as the Earth heats up, it starts radiating more heat to space, as I show here. But because of the greenhouse gases, otherwise this will be 4 watts higher. At the current temperature, Earth will be radiating much more heat back to space, and it will be cooling down. But because of all these additional greenhouse gases, more heat is accumulating, and then the temperature goes up until it radiates more heat to space, and then there's a new balance. So that's the radiation balance. And what we show in our research is that this imbalance, this difference, has increased. So the rate of warming has increased. It has more than doubled. So the planet is absorbing more than twice as much heat as it was 20 years ago.
And that is due to sulfur reductions?
Yeah, so that's in part, that's of course because of the increase in greenhouse gases.
Greenhouse gases, right.
And because of the decrease in aerosols. Over the oceans in 2020, the amount of sulfur which was being emitted reduced by about 80%. And that's because new regulation was introduced to have cleaner fuels or reduce the amount that's coming from the smokestack of ships. And there's about 50,000 ships sailing across the oceans, which use a lot of fuel and which were putting a lot of these sulfur particles into the atmosphere, especially over the oceans, which are dark and which normally absorb a lot of sunlight. But if there's these reflective particles and whiter and bigger clouds, which are longer lasting over the oceans instead of less, then there's more sunlight being reflected to space. And then if you reduce this by 80%, if you reduce the sulfur particles we added, if you reduce this by 80%, you can expect that there's less sunlight being reflected to space and more heat being absorbed. And that's a big part of the study which we published, which was led by James Hansen, Global Warming in the Pipeline. I understand why the regulation is there, and I value, of course, the health effects. As I mentioned, I do it for my work. I work on reducing the health effects for the 4 million women and children mainly that die from indoor air pollution. So I understand this very well. But if you look at the climate effects, you should take an honest look at what does this do to be able to take into account the associated risks for climate.
And so those risks essentially are that we had this abrupt reduction in the sulfates, aerosols. And so now that is going to contribute to a massive increase in heating, an unexpected increase in heating over the next few years.
Yeah, it's already happening, and it's unexpected. I think it's not unexpected by everyone. James Lovelock already told Shell in 1966 about the effect of sulfur and the cooling effect thereof. James Hansen already published a paper in 1990 warning about the cooling effect of aerosols, and that once we would stop emitting these particles, that we would see a rapid warming effect, especially if we wouldn't reduce the amount of greenhouse gas we were emitting, which we didn't do, of course. Since 1990, we've been emitting a lot of greenhouse gases. And then, so that's, James Hansen called this in 1990 the Faustian bargain, which is like a contract made with the devil, that we get all the benefits from using these fossil fuels without seeing the harm in the global climate impacts which it is doing. Because especially over the Northern Hemisphere, where all these particles were being emitted, that's where the cooling happened. And that's why we, even in the 80s, people were talking about global cooling, right? So some climate skeptics say, okay, first you say the planet is cooling, then you say it's warming. Yeah, because if you understand these different forces at play, then you understand how this can happen, how people can say it's cooling and it's warming, because that's what we have been doing. We've been causing global warming and regional cooling, and also global cooling. And now we are reducing this regional and global cooling.
What kind of heating are we talking about here? Because we're seeing crazy temperatures here in Canada. This year, we didn't have any snow until January. Heat records are being broken all around the planet. What do you foresee in terms of the actual impact this is going to have on global temperatures in the next couple years?
Yeah, so we are running this global experiment together. We don't know exactly what will happen. But if you see the increase in how much heat is the planet's taking up now, I think we can easily, or we should easily expect a doubling in the rate of warming, and especially that's centered over the Northern Hemisphere, especially the mid-latitudes, where all these particles were being emitted and keeping us relatively cool. So if you see a global warming, a doubling in global warming, then we might see a tripling or maybe a quadrupling in the rate of warming where we live, where we grow our food. So we should prepare ourselves for much faster sea level rise, much stronger storms, much more forest fires. Of course, we can pray that it doesn't happen, but still we should prepare ourselves for that, because hoping and praying, that doesn't change the physics, doesn't change reality, right?
And so this is a graph here. Could you go back to that graph? Because this clearly demonstrates the precipitous drop in sulfur emissions in the year 2020. How long does it take for that to translate into a noticeable heat difference? Like, is it 6 months? Is it several years? Is it instant?
It takes a lot. So it's the lifetime of these particles, the sulfate particles in the air, is about 1 week or 2 weeks.
Oh, wow.
Then they rain out, but then that's only part of the story. Because then once these particles are not anymore in the atmosphere, of course, the weather starts to change, because the weather was used to this load of aerosols being added to the atmosphere. And then, so for example, if you take away, maybe I can compare it to if you have a house and you take away the blinders from your window, sun comes in, right? But you don't see your house will not be immediately, let's say, in theory, it will heat by 10 degrees if the sun is shining through your window compared to if it's not shining through your window. But it's not instantly 10 degrees warmer. That takes time. If we keep it like this, if we keep the greenhouse gas concentrations like they are today, we will likely see almost all ice sheets melt, and then we'll have over 50 meters of sea level rise. Right? So they need to be aware, need to be made aware, and now they are being kept ignorant. The IPCC process is keeping people ignorant. The the World Meteorological Organization, and now a big report from the European agency, where they don't even talk about aerosols, let alone about sulfur, let alone about desulfurization. And with this, we are completely underestimating the near-term warming, and because of that, there will be many deaths. There will be many climate effects, including deaths and including wildfires and including extreme weather, which we are not preparing for at all. Because you need to take these things into account in order to prepare for what's coming. And if you don't even talk about it, or if you ignore it, or you pretend it's not happening, or even some lie about it, then of course the risk will be very high. And I call that gross negligence. Some call it scientific reticence. I call it gross negligence, because you're not informing people about the reality which is there, and that could cause very serious harm.
So you think that the IPCC is being negligible or negligent in their lack of attention paid towards the issue of aerosol masking? Is it that they just are not aware of it yet, or are they knowingly suppressing it?
The process causes it to be suppressed. For example, I showed you the synthesis report, and in the synthesis report, it's almost not mentioned at all. Somewhere there's a bit of mention about aerosols, but they combine it with methane, and they say, okay, if we reduce aerosols, there will be warming, but we can compensate that by reducing methane. But in practice, methane is going up much faster than the scenarios show, and the aerosols are going down. So that causes faster warming and less cooling, so much faster net warming, right? And these models don't take that into account. They don't take the reality into account. They have these scenarios which are not representative of reality. And that's what you all, I can show that here with, can you still see my slides? No? Yes?
Yep.
No. Yeah?
Yeah.
So these are models, climate models from Gavin Schmidt et al., which show, here you see the climate models, and this is how much sunlight are absorbed, how much sunlight is being absorbed in these models. And you compare it to these satellite observation, and in reality, there's much more sunlight being absorbed than the models assume, which causes much more heat accumulating in the system than the models assume. But even the lead author hasn't published, hasn't written about this and shared this with the media. So nobody knows about this, right? So it's and people are still ignorant about it.
So why do you?
But this is real.
Why do you think they are?
Sorry.
Why do you think they're ignoring this? Because it seems as though, the IPCC, a lot of climate skeptics often think that they are too, that their claims are not conservative enough. But you're saying that their claims are far too conservative, and that the situation is actually.
But they're saying it themselves. Their research shows it.
Right.
The research shows it's not me. Like, it's me. I'm saying it, but I'm just showing what their paper shows. Right. I'm showing you what the data shows, which they are presenting but not communicating. Of course, they're not apologizing, but with the data, they show that they have been wrong. And that unfortunately, we and the data we present are correct.
Yeah, and you're just basically reporting the data. You're not, as far as I know, making any sort of prescriptions on what should be done necessarily. But I find it quite odd that the IPCC is not calling attention to this when their main objective is to alert the public of, the warming trend. It almost starts.
That's not what they do, right? It's there's a lot of great scientists working on it, and I think there's somewhat of an abusive relationship going on because they're not being paid, and the government decides. The government representatives decide what is being communicated to the public. Of course, people can read the 4,000 pages of every single report. Most do not. But then, so it's not a healthy relationship. And then some research like James Hansen's research is not even included in the reports, right? So, and then now we see all this research coming out, for example, with about the AMOC, about the heat transported by the ocean to the north, from the southern hemisphere to the northern hemisphere by the AMOC, which is weakening now already, and that it could collapse maybe this century, right? And that's what James Hansen has been publishing about in 2016, and it wasn't even considered by the IPCC reports. And of course, there's big egos as well. You know, at the morning we published our paper, there were some IPCC authors who couldn't even have read our paper because it just got published, and they didn't. We had a preprint, but they didn't communicate with us before that, which they could. I did that as well when they didn't include the shipping emissions, right? So they should, if they have questions, they could talk to us. But then at the morning we publish it, they have all these strawman arguments saying, okay, there wouldn't be any warming if we would just go to net zero, right? But it's just a strawman argument. We're not going to net zero. We don't have the instant human extinction scenario. So it's a strawman argument. We have a scenario where we stabilize greenhouse gas concentrations at what they are today, which of course is also a scenario. It's not happening. Greenhouse gas concentrations are increasing, but so you cannot say, okay, your hypothesis is incorrect because if I take a completely different scenario, you are wrong. It's like, yeah, okay, if you live on a different planet, we have different rules apply for sure. I can agree, but so it's a very strange what's happening here. So all these it's really personal for some people. Well, we are presenting the data. They don't address the data we present. They just attack us personally, and I don't care. Like you can attack me personally, but the data shows what it shows. If you have to attack me, I don't care. Like,
yeah, the data doesn't lie, and eventually you're going to be vindicated, and they'll find a way to integrate this. But it's almost appears to me as though the IPCC is perhaps trying to manage public panic about this, because if what you're saying is true, then the implications are quite profound in terms of what we can expect. I mean, last year, people have already acclimated to this idea that we beat the record for forest fires in Canada by 300%. So that was just last year. So it was just off the charts. So could it be that this IPCC is in fact trying to manage public panic because the situation is worse than they're saying it is, contrary to the skeptics who are saying that the IPCC is just sensationalizing?
So who I think what's important to note is who is the IPCC, right?
Right.
We don't have a problem with the IPCC or with, let alone with certain scientists, but there are people who've been, they're individuals who have been underestimating reality, who have been not including this desulfurization because they didn't know, right? That's the response. The first response I got is like, no, we take it into account, or it's like we cannot be not taking this into account, right? It's like, but they are. We've known for this 15 years ago. 2008, the regulation was introduced. But these are scenarios and they are not reality, right? So that's what. So, but I think the scenario should reflect reality.
Yeah.
Especially 4 years after this regulation came into effect in 2020 on January 1st.
Yeah, and it seems as though, and I know you're saying that it's just certain individuals and it's not the organization as a whole. It just seems like if the IPCC is an organization which is trying to convince the public that there's a problem, you think they would seize upon the opportunity to show that, hey, it's much worse than we initially thought because now we have this issue of aerosol masking that we didn't quite factor into the equation. And you think that this would be something that they would be talking about on the nightly news, yet we don't hear anything about it. And I must presume then that perhaps there is some reason why they're not sharing this information with the public. Maybe they just don't have the the solution worked out, or they don't have enough data?
Well, I think what's an important reason for that is what I've experienced as well, is that almost always the first response is, so we should, aerosols cause cooling, sulfur causes cooling, so we should do it on purpose.
Right.
And then that's maybe also their own response, right? So it's a natural response. It's just it's a logical thought people can have, but that doesn't mean you shouldn't talk about it, right? It's not okay. People can think this, so we shouldn't even tell them. It's crazy, right?
You do have a certain fringe element who will immediately, when you start talking about geoengineering, it's associated with all kinds of like conspiracy theories, and immediately you get this pushback from people who are going to say, don't put stuff in the atmosphere because, and it's just going to be, I can already hear the conversation on Twitter. I can already hear the thousands of comments you're going to get from people who are saying, you want to put stuff in the atmosphere and chemtrails, and so even if you could get people talking about it, I unfortunately think that it's going to be such a divisive and contentious issue with what to do with this information that I personally am not very hopeful that we're going to find a solution. What do you propose the solution is, or have you even thought about what possible solutions might be?
I think the first step is to talk about it, and then people will talk about doing it on purpose, but also people will talk about, okay, what happens now?
And so what do you think the impacts are going to be? Like, what will this look like now moving into 2024? We know that El Nino is about to switch to La Nina, but you're saying that the heating effects are going to be still for about 6 months. What do you think, how is this going to affect the planet? Like, how are people going to experience this increased heating around the world?
Yeah, it depends a bit about where you're talking about, right? So certain regions, for example, Australia is now seeing around the Great Barrier Reef a lot of bleaching from the corals because the oceans are record warm, and we see record bleaching events happening at the moment. So that's already what's happening now. And I think I worry quite a bit because this situation we are in now, these temperatures which we see globally over the oceans, the current temperatures are record high, most likely higher than they have been in over 100,000 years. And we can determine that by looking at the corals, the temperatures, and the evidence from tree rings and deposition from lake sediments and from ice core data. So and all this data shows that it hasn't been this warm globally for over 100,000 years. Because of course, much of this time there was a glacial period, the ice age, and then so it was much colder for much of that time. But now it's record warm, and we don't know what a climate this warm really looks like because we're just experiencing what this looks like at the moment. And the example of Canada, right? Of Canada, all these forest fires are very worrying. And if you understand basic physics, that if the temperature of the atmosphere increases, it holds much more water vapor. So because it increases exponentially, 7% per degree Celsius of temperature increase. And then if it holds much more water, you can also have much more precipitation, but it also causes more evaporation because it can hold more water and take more water out of the ground or from the ocean, right? So all these forces, and then we should expect more extreme rainfall, like we saw in Europe and in Libya last year, and in many places around the world, more drought. The climate has already changed. We are we call it uncharted territory. We are in a period where we are about to reach a climate within the next decade, or maybe 2 decades, which we maybe haven't seen for 1 million years even. because we've never had this much greenhouse gas in the atmosphere. And it will take some time for the sea levels to be as high as they were before the last ice age, when they were 5 to 10 meters higher than they are today. While the greenhouse gas concentrations were much lower, right? We didn't have this forcing. There was just changes in solar radiation a bit. So, but if you change the forcing with this 4 watts per square meter I mentioned, then we should expect also multiple meters of sea level rise. How long that takes is uncertain. But if it starts raining on Greenland, for example, instead of snow, or on the West Antarctic ice sheet, if you have rain instead of snow, your snow disappears very rapidly, much faster than from sunshine, right? So and then you can lose very rapidly a lot of ice, and then we'll have much faster sea level rise, especially the east coast of North America.
Yeah, and there's also
on top of the sea level.
Yeah, there's also the albedo effect too. If that ice melts, less sunlight is being reflected. And so there's all these positive reinforcing feedback loops that we're really, like you said, in uncharted territory. And I guess one of the concerns is, how is this going to really impact people? Because it's not until it hits home that a lot of people are going to be convinced it's a problem. And because it's such a complex system that the climatology is such a complex science with so many variables. And I'm worried that most people won't really recognize it as a problem, much less commit to doing something about it until it's far too late. And the impacts on agriculture, I think, could blindside us. We don't know what the effects on the global food supply are going to be, for example. One thing I wanted to ask you about, or did you have any thoughts on that, or before I ask you next?
It's the speed of change which will have a lot of effect. Because if there's gradual change, you can adapt. If you have very rapid changes, you cannot really adapt. And I think that's a big challenge here. How we can adapt and what the effects will be, and how many people will be affected and survive. I don't know. Nobody knows, right? But we are learning that as we go. But we should, if we want to survive and if we want to adapt to the changes that are coming, we should take these real changes in the world into account.
So you're predicting more record temperatures for 2024 then?
At least for 6 more months, yes.
Okay.
And then, of course, can the September 2024 compete with 2023? I don't know. Maybe not. Maybe it can. It depends a bit on also the natural variability. But 2024 is already a crazy year. I think there was 1 million square kilometers of grasslands burning in Mexico, in
Texas.
In Texas,
yeah.
For example, just to mention one thing. But the coming months will be really crazy. I feel quite safe to predict that. Unfortunately.
Okay.
And there will be a sneak peek into the average future.
I mean, what do you think ultimately? I mean, we've talked a little bit about possible solutions, but it doesn't seem as though. Do you think? Can you imagine a world where they continue to put the sulfurs in, or are they going to go back to how it was before, or can you not imagine that as being a feasible, short-term solution to potentially cool things down, to remove the requirements of desulfurizing, or are we going to potentially see push towards geoengineering at some point?
We've already been geoengineering our planet, both by increasing these greenhouse gases and by increasing these aerosols. So we've been already giving ourselves time to do whatever we should be doing when we have the additional time. Did we use that time? No, we didn't. We didn't really, right? We use that time to build a lot of wealth and a lot of luxury, which we are all enjoying today, more or less. But we didn't really change our ways and make sure that we didn't increase the radiative forcing by 4 watts per square meter. That's not what we used our time for. And I don't see any evidence of us changing that if we would emit sulfur on purpose, whether it's over the oceans or further away from the coast, or whether it's in the stratosphere where it has less health effects, and where sometimes volcanoes already put some sulfur anyways, right? Or use different particles, whatever. I don't see any evidence of us using this additional time to the advantage of the planet. We should do that for sure. That's what James Hansen has been telling people for decades, his whole career, and few have been listening to him and his predecessors, right? So, but if we start taking stuff seriously, that's one of the tools in the toolbox, and whether we will use it, that's not up to me. That's a political decision. But yeah, it should be considered. It's the same as should India install these desulfurization systems. It's if you look at the health effects, you say, of course they should do it, right? But what are the climate effects? If India has a temperature of 60 degrees, for example, and loses half of its agricultural yield of a year, is it worth it? Right? I'm just giving a hypothetical scenario.
Yeah.
But I don't know. I think, as to my knowledge, nobody has looked at the scenario of what are the climate effects of India reducing the sulfur emissions from the coal plants by 90%, for example. I don't know. I haven't seen any scenario of that, so I cannot say whether it's a wise choice to do that, right? And I'm not saying they shouldn't do it. It's not. I'm not saying anything here, but I'm saying study it and take into account what will happen and prepare for these effects, and make the policies accordingly.
Yeah, because the deaths from heat could be more severe than the deaths from long-term chronic health effects of sulfur.
Yes, in 2022, 60,000 people died in Europe from extreme heat. That's many more. That's, I think, 5 or 6 times more than people died from the extreme flooding in Pakistan that year. Very few people know about it, but the Europe has now over 200 hours more sunlight per year, as we've compared to the 1980s, and that's contributing to much more heat, right? And if we also next year we will reduce sulfur emissions over the Mediterranean by another 80%. When they reduce the maximum sulfur fuel content from 0.5% to 0.1%, what effect will that have? I don't know. But it should be studied, and maybe make some scenarios, prepare for more extreme weather around the Mediterranean, where a lot of people live, a lot of people grow their food, a lot of people produce electricity with hydro dams, right? Take that into account.
Yeah, it seems that in light of the current geopolitical climate with an age of conflict, I believe it was a Polish politician who recently said we're entering a pre-war era. I cannot, even if by the most optimistic projections, I cannot comprehend how we collectively come together to resolve this predicament. What is your best and worst case scenario with respect to how this is going to play out?
If you take away these aerosols, especially if you take away the sulfur, you will see, for example, Canada, what is it? It's a bit difficult to see the colors, but that's a few degrees, 1 or 2 degrees of warming from reducing these sulfur aerosols, mainly sulfur. And that's Europe. It's the same. So multiple degrees of warming over over the northern hemisphere, especially over the land. And the ocean, there's a lot of uncertainty there. I think it's much worse because the ocean is darker and the ocean absorbs more heat and it takes more time. And then and because 90% of the heat accumulation in the world is going into the oceans. I have a nice figure for that. So the oceans cover about 70%, 71% of the Earth's surface, but they absorb about 90% of the additional heat. And then we reduce the amount of sulfur over the oceans by 80%. What is the maximum effect? I don't know, but I think it could be quite severe. And the worst case scenario is that maybe, multiplied by a factor of, I don't know, 5 or 10, I don't know. So of course, really, really extreme weather, which extreme storms, multiple meters of sea level rise this century. Those are the extreme scenarios.
What I just have an odd question for you here. What effect does forest fire smoke? Because forest fire smoke would be reflective. Would there be some odd balancing that happens with increased forest fire activity and the amount of reflectance? Would that be a cooling factor in a way?
Yeah, it's a easy question to ask and a difficult question to answer, because where does this smoke go? Does it blow over Greenland and deposit on the Greenland ice and darken the ice sheet and making the ice sheet absorb more sunlight and melt faster, right? So that's one option. If it blows over the ocean, it might absorb heat or reflect heat from the sun and decrease how much heat is going into the ocean, reducing the warming of the ocean. And then where do these forest fires happen? Do they happen over Canada, or do they happen over Latin America or over Australia? Australia has also had a lot of forest fires, and there's different studies on how that affects climate potentially and model studies. And so it's a very broad question. That's what this question shows. How difficult, how complex this is, because you understand if you talk about forest fires that these forest fires are not happening everywhere at the same time. That's the same with these aerosols, which we've been emitting. And if we reduce these, that also has different effects, because if you heat the oceans more than the land, that also changes weather patterns. That changes if the land is less. The difference between the temperature over land and temperature over the oceans changes. The weather pattern changes. There's a change in wind blowing from the west to the east or from the south to the north, and different altitudes. So, and then that of course that also changes where the smoke is blowing. So it's a really complex, and I think that's also I haven't talked about it yet, but these aerosols, and especially their effect on clouds, are the biggest uncertainty in climate science. That's also why it's so crucial to reduce this uncertainty. And that's the case not only for natural aerosols, because we don't even know how much natural aerosols there are. We don't know how much sulfur algae are emitting. We don't know how much sea salt is going into the atmosphere as acting as natural aerosols. And then how do our aerosols compete with these natural aerosols, right? So it's a really complex issue, and that's, I think, one of the main reasons. That's one of the main reasons why we are studying this also, is to reduce this large uncertainty.
Mm-hmm. Yeah, you talked in your conversation with our mutual acquaintance Nate Hagens about the concentration per parts per trillion, and how we're really talking about, what is it, like 1 to 10 parts per trillion when we're talking about sulfates. And you were talking about a comparison of greenhouse gas as in greater parts per million than water vapor in clouds. I'm wondering if you could just explain that to people, that help us wrap our heads around, the potency of this reflectance and how this factors into I think you made a comparison there where you said that if we could see CO2, the sky would be black.
Yeah, that's in certain wavelengths. That's quite interesting, and I can explain that to with my thermal camera, with my thermal imaging camera.
Sure.
It's a bit of a fun experiment. So you can see me, right?
Yes.
What can you see? So if you see a cloud in the sky, of course, aerosols, there's very little aerosols. You need very little aerosols to form a cloud. But without aerosols, there wouldn't be any clouds. And but you can see a cloud, right?
Mm-hmm.
Then imagine a cloud. The amount the amount of particles inside a cloud is over 1,000 times less than the amount of CO2 in the atmosphere.
Right.
And then if you see my glasses, you can see my glasses, right? You can see my eyes. You can see my eyes, right?
Yeah.
You see my, and then we like within our research, when we talk about what you can see with our eyes, we talk about visible light. So visible light, we can see visible light with our eyes. But now you can see the thermal image of my head. You cannot see my eyes, which are warmer than the rest of my head. But because it looks like I'm wearing sunglasses, because the glasses, like greenhouse, they absorb infrared radiation. So, and then here I have a trash bag. You can see it.
Yeah.
You can see it in my visible light image.
I can see it in your camera.
Yeah?
Yes. I can't see it in the thermal camera. I can just see it in the. Yes.
Yeah, that's what I was saying. Okay, and then you see it. You see my head is not in the bag, right? Now I put my head in the bag, so it's black. So it absorbs the black trash can absorbs visible light, but it doesn't absorb the infrared light, because you can see my hand through the bag. Here, I can even put it over my head. Don't try this at home. You can see my head with my glasses, which look like sunglasses, through the black trash bag, right? So that's just to explain that because our eyes cannot see certain things, doesn't mean they are not there.
Right.
Right. I can, for example, here, if you see the map going back to the North Atlantic, so I can add some heat to the North Atlantic, right? I can put my hand there. You can see my hands.
Yep.
And then so I'm adding some heat with my hand. And if I remove my hand, you can still see there's heat radiated back into the room from the Atlantic Ocean.
Which is something we wouldn't be able to see if we didn't have that thermal imager.
Exactly.
Yeah. That's interesting. I never knew. I wasn't aware of the black trash bag comparison. I thought that would block the actual, or at least some of the heat, but you could almost see yourself fully transparently using the thermal imager. That's pretty incredible.
Yeah, it looks like a transparent bag if you look at it in thermal imaging. And of course, if you would really look in detail, you can look at different wavelengths, like greenhouse gases are absorbing certain wavelength within the spectrum. So for example, blue, red, so within the visible light, there's different wavelengths which we can see with our eyes. But in the infrared spectrum, there's also these different wavelengths, and certain particles, certain greenhouse gases absorb different wavelengths of infrared radiation. And because of that, for example, CO2 absorbs different wavelengths of infrared radiation, and that's why it's a stronger greenhouse gas. It increases the amount of heat, and then if it gets warmer, there will be more water vapor in the atmosphere, and that is a water vapor. We call it the water vapor feedback, and then the additional water vapor also acts as a strengthening of the greenhouse gas effect.
So there's a lot more than meets the eye, and this is part of the reason why it's so hard for people to accept that this is a phenomenon, because of course you can't see it, but it's everywhere around us. Do you have any other important points that you think people should take away from this understanding of aerosol masking? Or do you think we've done the topic justice today? I mean, it's a very complex topic. I would encourage people to go and read the article, and I'll also post a link to a variety of different slides that explain this in great detail and maybe give people a visual representation. Is there anything else that you would like to add?
Yeah, I think if you want more details, I think with Nate Higgins, it's a bit maybe more technical than this conversation. It's and you can also ask me questions on Twitter or through my LinkedIn. I think that's I'm open to that. And I think it's important to note what I already mentioned. So it's important to note the It's important to note the uncertainty of this effect of these aerosols, and that it's the most uncertain part of climate science. That's why we really need to study this and decrease the uncertainty. I think that's good to mention another time.
Yeah, your conversation with Nate Higgins was great because, of course, as a natural research expert, I would encourage people, this is a good primer video, and then I'll link that one below, and we're also going to link your Twitter page so people can get some real-time updates with respect to the progress of your research. And that will hopefully help people to understand the severity of the situation, because I think there are a lot of people who are still, unfortunately, having a hard time coming to terms with the science, and I don't understand the psychology of that for the life of me. But it's just a reality we have to deal with. And you spend a lot of time on Twitter, so you know my pain.
It's like trying to convince people the Earth is round, like whether trying to convince someone who believes I don't know, in this flying spaghetti monster or whatever they believe in, that it does or not exist, or someone who doesn't, trying to convince them that it does. If someone really believes something, if people don't want to believe something, yeah, what can you do?
Well, I think part of the problem is I'm looking at this research paper, Global Warming in the Pipeline, and it's such an incredibly complex, it's so much data, so much information, that how can you almost have to make that there needs to be somebody who can help the public understand this simply in a way that they trust. And I think one of the reasons why a lot of people are so reticent about accepting the reality of the situation is because the people who are in charge, the leaders of the world, they're not leading by example, right? So you have these leaders who have these giant mansions and private jets, and they're telling everybody they have to reduce their emissions, and so it's until you have people who are willing to lead by example, I think it's very unlikely that you're going, it's always going to be a polarizing issue. And unfortunately, maybe we're just doomed to
but even then, we can lead by example in the Netherlands by riding our bicycle. But if you live in Italy and you have to climb a mountain every day, it's not as easy to ride a bicycle. Or if you live in the United States where you don't have bicycle paths, you can see our example, but it's not as easy. And I think that's just an example of that it's the world is built around the current infrastructure. I think Nate Higgins told you that as well in detail. That we have the infrastructure. That's why we also our research is called global warming in the pipeline. But part of the global warming in the pipeline is also the emissions in the pipeline, the infrastructure that is there, and how much greenhouse gas will still be emitted with the infrastructure. Because we cannot tell people to stop flying 100,000 times a day. We cannot tell people to stop driving their 1.2 billion cars, which they own together. Right? That's because that's the infrastructure they use to transport themselves. And we cannot tell them to stop heating their houses instantly, right? Because they will freeze. And that's reality we have to deal with. And that's why, yeah, but in the meantime, we have to take the reality into account and to consider what will happen and prepare for that.
Well,
that's crucial.
One thing I really like about your approach, and one of the reasons why I wanted to get you on, is because you do just focus on the data and you're not making any prescriptions. And I think for most people, what happens is they are on board with the data, and this is something me and Nate talked about, is that they can understand the data, but as soon as somebody starts making prescriptions as to how they need to change or what they need to do, that's when they immediately start to get defensive. So if we can just present people the data, give them time to process it, give them time to come to terms with it before immediately saying, well, you have to do this, this, and this virtue signaling stuff where, you know, you're trying to put in all these regulations and mandates. Just give people some time to really understand what's happening. And then over time, inevitably, they come to the realization that, okay, this is the reality. Some things are going to have to change. And that's, you know, that's why I liked your approach, is because you just focus on what's happening as opposed to trying to, you know, push for policy changes, which ultimately have to happen. Don't get me wrong. I understand that has to happen. But until we really fully understand what's happening, then these unintended effects, much is the case with aerosol masking, like we can have a policy that seems great, remove the sulfates, but the unintended consequence of that is, of course, increase heating. So, you know, it's great that we wanted to make that policy change, but maybe we didn't think it through. So you have this slide here on the screen. What is this that we're looking at?
So what you see here is since 1950 to 2023, you see on the top global emissions of sulfur dioxide. So there's a fluctuation over the months. And then there was a big drop in 2020. And you see here over the emissions over the oceans. You see again an increase until about 2010, and there's regional regulations. And then in 2020, there's this enormous drop in sulfur emissions. And then here, I show you the temperature of the northern hemisphere mid-latitudes. And that's the sea surface temperatures in these regions. You see the temperature of these oceans started to decrease first, temperature normally, and then it's rapidly started to increase as we started to decrease sulfur and, of course, increase the greenhouse gases, which I don't show here. But then you see that, especially over the last years, the oceans got much and much warmer. And then over the over the Southern Ocean, you see that there's an increase, and there's almost a linear increase. It just kept increasing as we kept increasing the greenhouse gases. But there were not, as you can see on these maps, there was not much sulfur being emitted over these regions. And then here, this is the global view. And then you can see, again, there was some increase, not much, and then it started to increase faster and faster. And now there's a big spike over the global ocean temperatures in the recent years as well. And then, of course, that correlates also with El Nino, which is more in the tropics. But we can expect this to start to keep increasing faster for a while, and then maybe it will level off a bit. But then, especially with the coming years, we should see much more faster warming for a while.
Wow. Well, that really puts it in perspective. I definitely want to encourage people to go and check out your work on Twitter, and just, keep us posted on any new developments. I think that's the best way for people to keep in touch with you. And let's just hope that something can be done about this. I think in terms of bringing awareness to this, that's the first step. And thank you very much for coming out today.
Thank you very much for having me on, Nate.
No
Good
problem.
to talk to you.
The best way to support this channel is to support yourself by gearing up at CanadianPreparedness.com, where you'll find high-quality survival gear at the best prices, no junk, and no gimmicks. Use discount code PREPPINGGEAR for 10% off. Don't forget, the strong survive, but the prepared thrive. Stay safe.